So now our next topic is types of vector. First we will discuss over here that is called equal vector. That is called equal vectors. What is these equal vectors? Suppose we have two vectors. One is A vector, another one is B vector. And these two vectors are said to be equal when they have an equal magnitude, and same direction then it should be said it is an equal vector. So it is a very important concept. Now if I talk about that, if A vector is equals to B vector, then also it must be satisfied A is equals to B. The first one is in vector, second one is in magnitude. But if A is equals to B, it does not implies that A vector is equals to B vector. That is an important concept, just you need to remember these things. So geometrically we can also prove it, but we are not going into the deep of the topic right moment of time. Otherwise you will get bored to learn physics. But one thing you should remember over here, so geometrically if head of one vector coincide with the head of the other, and so do the tails coincide, then the vectors are said to be equal. So what is the head and tail, that you should know. Suppose we have a, here it is an initial position, okay, and this is a vector that we draw over here, and suppose here is the position, that is starting position, and it is in direction, right? This position I give the name A, and this position I give name of B. It is clear, right? So this position is called the initial position or start position or point of tail. It's a point of tail. So point of tail is also known as initial position or start position. Terminating position or terminating point is called the head of the vector, right? And this is the position, this is called the directed line segment. This is directed line segment. Clear? This is called directed line segment. So mathematically we can write here AB vector should be negative BA vector. Why? Because the direction of AB is opposite to the direction of BA, or direction of BA is opposite to the direction of AB. So when, so here suppose a vector we have that is called A vector, but we need to find out its magnitude. It will come under the modulus, then we will get the magnitude, that is A. It means magnitude of A vector is equals to nothing, just the length of A vector. Hope it is clear. Similarly B, C, D, whatever you want to like. Alright. Now we understood that equal vector. Now we need to learn what is parallel vector. Parallel vector. What is this parallel vector? Suppose we have a two vector, that is vector A and vector B. Two vector. This two vector will be parallel if they satisfy two options or two rules. The first rule is both have same direction. Both have same direction. Right? Second, magnitude of one is scalar multiple of magnitude of other. Right? Suppose we have a two vector, right? This is vector A and this is vector B. So from the picture we can say B is equals to nothing, it is an 2A. Right? It means mathematically we can write B vector is nothing, it is a 2A. It is a scalar multiple. So magnitude of B vector is twice the magnitude of A vector and both have the same direction. So in general we can write A vector is equals to K B vector. What is this K? What is this K? K is a constant. Any constant. Any constant. But if it is an A vector and this is a B vector, but whereas it is in minus 2A, because here the value of K is nothing, just a minus 2. So both have the same, both have opposite direction. Both have opposite direction, but one magnitude of one is a scalar multiple of magnitude of others. So these kinds of vector is called the anti-parallel vector. Anti-parallel vectors. This kind of vector is called anti-parallel vectors. Clear? So if I repeat it once more, then what we will get, this B vector is equals to minus 2 of A vector. It means the magnitude of B is twice the magnitude of A and both have opposite direction. Right? So magnitude of A is K times the magnitude of B. If I write it this way, mathematically, that is then K into B vector. Alright, mathematically. So it is only possible if K is less than 0. Right? But here, if it will be parallel vector, then it should be K should be greater than 0. And for anti-parallel, it should be K should be less than 0. Right? Next, collinear vector. Third is collinear vectors. What is this collinear vectors? When the vectors of A, suppose this is a vector A, right? This is a vector B, right? This is suppose vector C. C means here minus 3A, B is here 2A. Here A and B both are parallel vector. A and C is an anti-parallel vector. But what is the collinear vector among these three? When the vector, these three vectors under consideration can share the same support or have a common support, then consider vector as collinear vector. Common support or same support means under one plane, right? So they have a common support. In physics, that is called the common support. Right? I hope it is clear now. Next is another important, that is called zero vector. Zero vector. What is this zero vector? It is can be written in this form: 0, there is a vector symbol. So the vector having zero magnitude, right, and arbitrary direction. What is arbitrary direction? That is not known to us. That is called an arbitrary. In which direction it is going, that is not predicted. That is called an arbitrary direction. When any vector has two features, it is called the zero vector. For example, mathematically we can prove it in different ways. Suppose a vector plus negative a vector, it becomes 0. That is also a vector. B, if a vector plus b vector, the sum of these two vectors is becomes 0. It is only possible when a vector is equals to negative b vector. Suppose a constant that is called the k into 0 vector, it becomes a 0 vector, because multiply any number with 0, it becomes 0, right? Fine. So this is, I hope it is clear to all of you, right? Now there is another vector that is called unit vector. What is called unit vector? What is a unit vector? Suppose a vector that is called a vector. When a vector is divided by its magnitude, is called a unit vector. For unit vector of A, for A is A and this symbol. This is called A cap or A hat or A carat. So what is the unit vector of B? Now you can try it. So unit vector of B should be B cap or B carat or B hat. So what is the magnitude of A cap? That is 1. What is the magnitude of B cap? That is also 1. What is the magnitude of C cap, that is also 1. What is the magnitude of X cap? That is also 1. It means, it means, so I hope that you people are getting interest to read it and understanding the situation. Since A cap means an unit vector mathematically written as A vector upon A, that we have written over here. If I multiply these things, cross multiplication, then A vector is equals to A cap into A, right? So it means a vector has two essential ingredients. Here we get magnitude and here we get direction, right? So what we concluded over here, it means unit vector gives us the direction, right? From this equation we find out it. Hope it is clear. There is a no conclusion of it. Now fixed vector. Fixed vector. What is this fixed vector? Very important. It is very important. Fixed vector. Suppose here now the line is fixed. Now the line is gone over here. So it is an A vector. Suppose. So this A vector whose initial point or tail is fixed. That is an initial point. We cannot extend it here. We can extend it here. So this is called the fixed vector. The fixed vector has another name, that is called localized vector. That is called localized vector. What is an example of the fixed vector? The first example, number 1, position vector. Position vector. And number 2, displacement vector. Right? Now we come to another position, that is called the free vector. What is this free vector? If it is initial point or tail is not fixed, tail is not fixed, then it is called the free vector. Free vector has another name, that is called non-localized vector. That is called non-localized vector. So velocity vector is an example of the along a straight line is a free vector. So example, velocity vector. Right? It is clear? Next is the negative vector. What is the, if the direction is different, that we all know, that is a negative vector, that we have already studied it. So now the important is the co-initial vector. What is this thing? The co-initial vectors. Very important. What is the co-initial vectors? So I am making a draw. I'm drawing one picture. I'm drawing one picture. Um, oh, I'm drawing one picture. Margot, drawing one picture. That is a very important here. This is a picture. Suppose this is a vector. It's not necessary that you need to write in the capital letter. You can write in the small letter also. B vector. This is suppose C vector, and this is a called D vector. So what is a co-initial vector? Co-initial vector are those vectors which have the same initial point or tail. The initial point is same, that suppose it is 0, right? So this vector becomes a co-initial vector. But if suppose it's change this, and this, if it is like this, well, they have a common terminating point. Here it is a common initial point, it has a common initial point, but here common terminal point. So when there is a common terminal point, it is called, what it is called? It is called co-terminus vector. It is called co-terminus vector, right? I hope these things are very clear to you all. Now, I just want to tell you another thing. We have read the unit vector. Under unit vector, we can write as a j cap, I cap, j cap, and k cap. These all are an example of the unit vector. Suppose we are drawing one three-dimensional picture over here. Generally, we say it is x-axis, it is y-axis, and it is a z-axis. So towards an x-axis it is I cap, towards y-axis it is j cap, and towards the z-axis it is k cap. Clear? Hope these all things are very clear to you. Thank you very much. Have a nice day.